Hello, ladies and gentlemen. This is Mr. Rowe. I'm going to go over the sum or difference of cubes real quick. I'm going to show you the two patterns first. I'm going to show you a couple of examples. So here are the two patterns. So if you are given a cubed plus b cubed, then the pattern that you're going to fill into is a plus b, and then a squared minus a times b plus b squared. If you are given a cubed minus b cubed, you are going to use a minus b, and then a squared plus ab plus b squared. And to remember this, I'm going to tell you this little, I'm going to change color so we can see it. This little saying right here. So, same, opposite, always positive. And I'm going to abbreviate positive. I hope you don't mind. So if you take a look, if it's plus a squared plus, or excuse me, a cubed plus b cubed, same, opposite, always positive. That just tells you how to remember the signs. If it's a cubed minus b cubed, same, opposite, always positive. So just kind of a quick way to help you remember the signs so you don't have to memorize both patterns. If you want to memorize both patterns, that's also okay. Because remember, the only way you can learn is the way you learn. So let's take a look at a couple of examples. So now here are some basic examples. So let's say we had, for example, 64 x cubed plus 27. Well, because it's plus, I already know, same, opposite, always positive. And so now all I need to do is find a and b, fill it in, and simplify. So a is going to equal the cube root of the first term. So I'm going to find the cube root of 64x cubed. Well, the cube root is 64. 4 times 4 is 16. 16 times 4 is 64. So that's 4. Cube root of any variable with an exponent, divide the exponent by 3. So the cube root of x cubed, 3 divided by 3 is 1. So x to the first power, or just x. And then b, again, cube root of the second term. So cube root of 27 equals 3. And so now we just fill into the pattern. So a is 4x, so 4x plus b is 3. A squared is 4x squared, and I'll simplify that in just a second, minus a times b, so 4x times 3, and then always positive, plus b squared, so plus b, or 3 squared. And then just simplify it so that we're done. 4x plus 3. 4x squared is 16x squared. 4x times 3 is 12x. 3 squared is 9. And that's factored. And here's kind of the rules for these things. This second thing is always a trinomial that will never factor. This first thing could be a factor that will factor again. So you have to watch that first factor. Second factor, never have to worry about it. It's always just going to be part of the answer. Okay, so here is another example. So we had x to the 12th power plus 8. Let's do minus this time. We did plus first time. Let's do minus this time. Okay, so this is minus. So our pattern, same, opposite, always positive. Okay, and again, we need to find A and B. So A is going to be the cube root of x to the 12th power. And remember, I just told you to figure out the cube root of a power to an odd, or not odd, but a exponent that's divisible by 3. Divide by 3. 12 divided by 3 is 4. So that's going to be x to the 4th power. And then B is going to be the cube root of 8. 2 times 2 is 4. 4 times 2 is 8. So the cube root of 8 is 2. And so now we're going to fill into the pattern. A is x to the 4th minus B, which is 2. And then we've got a squared, so we've got x to the 4th squared plus x to the 4th times 2 plus 2 squared. And then we're going to simplify it. And that's going to be x to the 4th minus 2. And then x to the 4th squared, multiply those exponents. That's going to be x to the 8th plus 2x to the 4th plus 2 squared, which is 4. And that's factored. All right, so now, on occasion, you're going to have some where you have to factor out something first. So let's take a look at one where you have to factor out a common term first. And this one actually has 2 variables. So we're going to see a couple things that you can see. So first thing I want to do is I want to look at the numbers. I noticed that 81 is not a perfect cube and 375 is not a perfect cube. So what I do is I look at both terms and see what they have in common. Well, they definitely both have x's in common, so I can pull an x out. They also are both divisible by 3. 81 is divisible by 3, and so is 375. So I can pull a 3x out of that and then factor what's left. So 81 divided by 3 is 27. And I pulled an x out, so that's going to leave x cubed. And then it's going to be plus 375 divided by 3 is 125. And then I pulled an x away, so we got y cubed. So now we're going to factor this part that's left. It's a plus, so I know I've got a plus b. Let me rewrite that. And then we've got a squared minus ab plus b squared. I'm trying to save a little bit of room so we can see everything. And so that 3x, let me follow my steps here. I need to find a, which is the cube root of 27x cubed. Cube root of 27 is 3. Cube root of x cubed is x. And I need to find the b, which is the cube root of 125 y cubed. So cube root of 125 is 5. Cube root of y cubed is y. And so now I'm going to write my factors. And so the 3x X has to come along, and then I fill in. So I've got 3x plus 5y, and then I've got a squared, so 3x squared minus 3x times 5y, and then plus 5y squared. And I'm going to try to get a little line in there. There we go. And so now you just simplify it to get your final answer. And so our final answer here is going to be 3x, and then we got 3x plus 5y, and then 3x to the second power is 9x squared minus 15xy plus 25y squared. And that's the whole thing factored. So look for a GCF. The GCF comes out. Then you factor what's left. So I hope this helps you with the sum or difference of cubes. If you have any further questions, send me a teacher message or make an appointment for a help session.